Hey everyone! Today I've got some exciting news from the cosmos, thanks to the incredible James Webb Space Telescope, JWST. An international team of astronomers, led by researchers from the Max Planck Institute for Astronomy, has discovered a brand new exoplanet orbiting a star in the nearby triple star system, Epsilon Indi. And guess what? This new planet is a cold superjupiter. So, what's so special about this discovery? Well, this superjupiter has a temperature around 0 degrees Celsius and orbits its star at a distance similar to Neptune's orbit around our Sun. This was made possible by the JWST's amazing ability to capture images in the thermal infrared spectrum. It opens up the possibility of finding more planets like this one, which are similar to Jupiter in mass, temperature, and orbit. Elizabeth Matthews, the lead researcher, said, "We were thrilled when we realized we had imaged this new planet." The team's initial surprise came from noticing that the bright spot in their images didn't match the expected position of the planet. Previous studies had identified a planet in this system but had underestimated its mass and orbit. Thanks to JWST, they got it right this time. This planet, now named Epsilon Indi, orbits the main star of the Epsilon Indi system, a red dwarf slightly smaller and cooler than our Sun. The JWST data shows that Epsilon Indi is about 6 times the mass of Jupiter and has an eccentric, elliptical orbit ranging from 20 to 40 astronomical units, AU, from its star. 1 AU is the average distance between Earth and the Sun, roughly 150 million kilometers. One of the coolest aspects of this discovery is that it's the first time an exoplanet has been imaged with JWST without prior ground-based imaging. This planet is much colder than other gas giants JWST has studied so far. The images show a bright dot, which is direct evidence of the planet's existence, unlike the indirect methods like the transit and radial velocity techniques. Only a few cold gas giants orbiting stars similar in age to our Sun have been found, and those were usually inferred indirectly. But with JWST's capabilities, astronomers can now directly image these planets and study their atmospheres. This helps us understand the late stages of planetary evolution and refine our models of planet formation. Finding these cold gas giants is tricky with traditional methods because they're far from their host stars and very cold. Their wide orbits mean they're unlikely to produce transit signals, and measuring their signals with the radial velocity method is challenging. But the JWST's MIRI camera, equipped with a coronagraph to block out the star's light, makes it possible to directly image these planets. The team also found imaging data from 2019 that supported their findings, showing the planet's position exactly where it should be if it belonged to Epsilon Indi. They even began studying the planet's atmosphere, noting that it's fainter than expected at short wavelengths, possibly due to heavy elements or a cloudy atmosphere. Next up, the researchers aim to obtain detailed spectra of Epsilon Indi to better understand its climate and chemical composition. They also hope to survey other nearby planetary systems to hunt for more cold gas giants. This discovery is a huge leap forward in our quest to understand how gas giants form and evolve. Stay tuned for more updates, and don't forget to subscribe for the latest space news and discoveries.